Question number 6 says, both graphs show the world's major spoken languages. Which graph makes the use of Mandarin appear almost 3 times that of English, and why? So technically this one was used on a previous question up here. I don't need it. I don't even need to look at this. Mandarin here, Mandarin here, English is here, English is here. Now, if I'm looking at these and I draw a line over here, that's about half. I draw a line over here, this is about a third. We did a worksheet that kind of talked about how do we, I guess, mathematically cheat. We're putting the numbers on correctly. That's going to be the same number as this. This is going to be the same number as that. How come this one, B, looks like there's a way big difference between the two? What do we tell you to look for? And actually, it's kind of cool that this one, there's only one small difference. We had you take a look, interval 200, or not 200, 200 million, 200 million. How come I can get a difference on that? Glad I waited till you're on with it. That's awesome. Alexis.
Well, they didn't set to 0, so it made it look bigger.
Totally. If I extend this down to here like it should be, it's the identical same graph. We can slightly cheat by doing a broken graph, or we can make the intervals different. Just like on the line graph on the front on temperature, I told you if you start at 0, you can almost flat line that line temperature one. If you want to start at 70, I can make it look like there's a big difference in the temperatures. Based upon your intervals and what number you start with or what numbers you skip. So, why does that happen? I skipped 0. Last but not least, number 7. It says, choose an appropriate display, then make a display. High temperature on July 4th. I'm going to throw temps over here in degrees Fahrenheit. I'm going to throw years on the bottom. And I'm going to say 1998, 99, 2000, 2001, 2002. 1998, 1999, 2000, 2001, and last but not least, 2002. Now, totally your choice how you want to do this. I had just talked that if I start this at 70, 75, 80, 85, how far do I need to go up?
90.
Oh, I almost got to extend my graph a little bit, sorry. 90, and then, yeah, I can go just a smidge up from there. 1995, what's the temp? Or 1998? What's the temp in 1998? 82. Now, I prefer, anytime I'm talking about years, and I have varying measurements, a line graph shows it really well. A bar graph would do the same thing here, but technically you want to show change over time. Change over time is a great way to use a line graph. 1999, 91. Ooh, I use my over 40 eyes here. Woo! 2000, 85. Whoa, big time drop. Big time drop from 1998. 2001, 77. 2002, 83. Now, just a matter of connecting your lines. Now, your graph could have absolutely looked way more, I kind of almost say tamer in terms of flat, if you would have included all the numbers from 0 to 100 and counted by 10s. Or if you went 0 to 100 and counted by 20s, you'd make it look like there's hardly no change in the temperatures at all. Last but not least, it relates really well to question 6. If I want to make this look gigantically steep and plummeting way down, instead of counting by 5s, what would I count by? 1s. You want to make it look monstrously big, count by 10s. You'd have to make your graph really tall though. So just how you put the numbers on the left side would definitely affect what your graph looks like. It won't change what the numbers are, but it'll affect its appearance.